Good morning students. Welcome to SRNK Government Degree College, BANSWADA. This is V. Narsimlu, Faculty of Physics, Department of Physics. So students, last class we were discussing about the different spectral series of hydrogen atom. The Bose scientist has determined level diagram can now as we have to discuss the important today topic is represented by explanation of atomic spectra. Explanation of atomic spectra. So this is the today's important topic. So what is the explanation of atomic spectra is indicates means already we known. So according to spectral series of an atom can be classified into two diagrams. One is represented by orbital diagram and second is represented by the energy level diagram. So these two diagrams can be used to we have to represent the spectral series of an atom So now one by one we have to discuss. So let us we have to take the first is orbit diagram. What is the orbit diagram is indicates? This orbit diagram is represented by the according to the general expression of radius of the an electron in a hydrogen atom. What is the nth radius of an electron in a hydrogen atom of a Bose atomic model? That is Rn equal to n square h square epsilon naught by pi m e square. So here n is the number of electrons, or it is also known as a number of orbitals, and h is the Planck's constant, epsilon naught is the permittivity of the free space, and m is the mass of electron, and e is the charge of electron. Due to this radius, different spectral series they are such as Lyman series, Balmer series, Paschen, Brackett, and Fund series are obtained. Fund series are obtained. This can be we have to represented by the following orbital diagram. So or figure. So what is the orbital diagram figure is indicates. So students, this is the very important orbital diagram. This is the very important orbital diagram. See here. So it is indicated by the orbital diagram. So in the orbital diagram, let us we have take the what is the dot is a nucleus, and around nucleus in circular path electrons can be revolving. So when an electron is revolving in a first orbit, so it is represented by n equal to 1. So if n equal to 1 we have to taken, it is called as a first orbit. It is called as a first orbit. Then n equal to 2 is called as a second orbit. So that is the first shell is the k and second shell is L, and n equal to 2 it is called as a third orbit or M shell, and n equal to 4 it is called as a fourth orbit or fourth stationary orbit, it is called as a n, and n equal to 5 O, n equal to 6 P, and n equal to 7 Q, and so on and so forth. Different orbitals can be we have to drawn in a orbital diagram. So in this condition or in this diagram, now let us we have to determine different spectral series. How to these spectral series can be we can represent? Means here simple. Now let us we have to take the what is n equal to 1 means first orbital we can take. So okay, when an electron can be jumps from the outermost orbits to okay first orbit is called as a Lyman series. So here this is the what is here first n equal to 1 means first orbit, second orbit to electron jumps, okay, third, fourth, fifth, sixth, seventh, eighth, so on and so far. Here the continuous okay lines are produced. This continuous lines is called as a Lyman series. This is called what is a Lyman series. Similarly, okay, what is the Balmer series, students? Balmer series can be defined as the when an electron jumps from outermost orbits to the okay second orbit, n equal to 2 means second orbit is called as a Balmer series. So therefore, in Balmer series, okay, let us we have take the n equal to 2 or it is called as a L shell. So here okay the continuous lines or vertical lines are fall into the second orbit is indicated by the Lyman series. Okay, now what is meant by the Paschen series here? The Paschen series can be represented by when an electrons can be jumps from the outermost orbit to the okay third orbit is called as a Paschen series, and these are the spectral series, spectral lines are indicated. And similarly bracket series is represented by when an electrons or jumps from outermost orbits to the okay fourth orbit is called as a bracket series, and fund series is represented by the when an electron jumps from outermost orbit to the okay fifth orbit is called as a fund series. So as like the okay different series can be okay indicated by or represented by in a orbital diagram. So according this orbital diagram, what we can understood means okay according to this okay diagram, the following important okay factors are okay obtained. What is the factors here? First okay pointer factor is represented by according to this diagram, the orbits corresponding to n1 equal to 1, 2, 3, 4, so on and so far we can take. These are called or indicates the K, L, M, N, O, so on and so far shells are stationary orbits. And second point is represented by the excited state of an electron has more energy but less stable. See here students, okay, this is the very important question for PG examinations. The excited state means okay the stable here okay higher energy levels. Okay, when an electron is contained in higher energy levels or excited states, the electron having what is here more energy but less stable. Okay, so then the third important point of okay orbital diagram is the ground state of an electron has the less energy but more stable. So that's why ground state and electrons having the what is here less energy but more stable. So as like so different okay here energy and stability of the electrons will be takes place. Then afterwards, now let us we have to take the another point is represented by okay the electron returns to the ground state after 10 to the power of minus 8 seconds, either in one step or in intermediate step. So when this point will be takes place students, means when an electron can be jumps from the ground state or lower energy state to higher energy states, okay, after 10 to the power of minus 8 seconds means the electrons are does not having the long time in a excited states or higher energy states. That's why after 10 to the power of minus 8 seconds that electrons can be again comes to the ground states. So it will be takes one step or in intermediate steps will be takes place. So this is the important okay point of it. So for example, if an electron jumps from n equal to 4th orbit to n equal to 1 orbit. And a 4 orbital to first orbital when it is jumps in one step. This is represented by the one step. Or alternatively 4 to 2 we can take, 2 to 1 we can take, or 4 to 3 we can take, 3 to 1 we can take, or 4 to 3, 3 to 1, 2, 2 to 1 in each step is takes place. So therefore the electron radiates the energy is equal to the difference of the two states whose frequency is given by, so En2 minus En1 is equal to h nu. This is what is here, the photon energy equal to h nu, means is the total energy of the photon you can represented by when an electron can jumps from higher energy level to lower energy levels. Then the equal to h nu energy of the radiation is emitted. So this emission of radiation can be observed by simple example of rainbow you can take. Rainbow we have to consider in the different colors are appear due to visible frequency nu. Nu is the visible frequency. That's why different colors we can appear, we can see. So therefore here when what happen here, the radiation is when it is produces or when it is the energy emitted, because of the energy difference between the or the difference between the two energy levels, higher energy level minus lower energy level, when equal to the h nu or frequency of an electron, then so it is indicated by the radiation or emitted energy of the photon is indicates. So next point is in this way the different members of the series are obtained. See here students, we are studying last class Lyman series, Balmer, Paschen and Brackett fund series as we were obtained first member, second member and limiting member is determined. Understood here by using the the wavelength formula or wave number formula or Rydberg formula is used to. So how to the first and second members can be produced means the energy differences is equivalent to the frequency of the photon or energy packet. This is the main concept of the first and second members of the series are obtained. So hence the number of atoms involved to continuous lines are appeared. So in spectral diagram, so in see here in this spectral diagram we are obtaining the different what is here lines. How to these lines are produced? So here the continuous lines will be produced. This is vertical lines are produced. How to these vertical lines are produced means the number of atoms can be involved in this energy transmission to produce the what is here the continuous lines are generating or produces. So appeared. So this is the what is the main important point of the orbital diagram of an electron which is jumps from the higher energy levels to the lower energy levels. So according to this we have to briefly studied about the what is their orbital diagram. Then afterwards now let us we can take the second diagram is represented by what is it, energy level diagram. Which diagram here, energy level diagram. So students, what is the second diagram, energy level diagram. What is the energy level diagram is indicates the energy level diagrams of the spectral series of an atom as shown in below here. So this is the the simple and excellent energy level diagram of an electron or atom. So here see, so in left side this is the energy in electron volts is indicates. In right side here orbital numbers n equal to 1 2 3 is there, orbital numbers, and when we have take the what is here this n equal to 1, it is called as a lower energy level or ground state energy level. N equal to is upper energy level or higher energy level, and so on. So far we can take n equal to 3 4 5 and so on. So far we can take these are the okay, excited state energy levels. So if n equal to 1, so what is the energy of the ground state? Minus 13.6 electron volts. N equal to 2, okay, minus 3.4 electron volts, and n equal to 3, okay, minus 1.51 electron volts. N equal to 4, minus 0.85 electron volts. N equal to 5, minus 0.54 electron volts, and so on and so far. N equal to infinite we can take. Here 0 electron volts is comes. So this is the different energy levels of okay, an electron. So here when an electron will be jumps from higher energy levels to the okay, first energy level or first orbit, means when an electron so jumps from outermost orbit to first orbit is called as a Lyman series, and okay, second orbit Balmer series, third orbit okay, Paschen series, fourth orbit is bracket series, and fifth orbit is represented by the Fund series. So these series spectral lines can be main. We have to draw the spectral lines. That spectral lines can be represented by okay, vertical lines, and horizontal lines are represented by the energy levels. Understood here? So according to this, here above that, what is the thick lines are there? This is thick lines is called as a continuous spectral lines. Continuous spectra is produces as like this is indicated by the energy level diagram. So in examination he will ask the okay, draw the orbital okay, diagram and energy level diagram to explain the spectral representation of the hydrogen atom. So that's why okay, these are the very very important. According to this diagram, now let us we have to study the following points, or we can understand the following points. What is the first point? In this diagram, discrete energy states to the atom are okay, represented by horizontal lines. So what is the, just now I said the discrete energy levels. The discrete energy levels of an electrons can be or atom can be represented by the horizontal lines. N equal to 1, 2, 3, 4, 5. These are the okay, what is the horizontal lines is indicated. The second point is represented by the transition of the atom from one state to another state, giving rise to spectral line, okay, is shown in a vertical line. So here see students, when an electron can be okay, transmission of electrons from one state to another state, or atoms from one state to another state. See here, okay, n2 to n1 we can take, n3 to n1, n4 to n1, and n5 to, and as like okay, electrons can be jumps or atoms can be jumps from one state to another state is represented by the vertical lines only. So here dotted lines is represented by the here limitation of the n equal to infinite okay, number of okay, orbital to okay, we can take the first, second, third. It is the okay, limiting okay, what is here energy state is indicates as like okay, the transmission of the atoms from one state to another state is gives the what is here okay, spectral lines are. It is indicated by the vertical spectral lines. So as like when we have taken the what is the vertical spectral lines is indicated by the an electron or atom, and horizontal spectral lines are represented by the energy levels. So therefore according to this okay, the last point is represented by, therefore the line emission spectrum of okay, hydrogen atom is completely and okay, correctly represented by the Bose theory. So Bose atomic model, what is indicates here? According to the Bose atomic model, okay, the line emission of the spectrum of hydrogen atom is okay, thoroughly and excellently and correctly explained by okay, this theory only. So as like the Bose atomic model is okay, represents the spectrum of hydrogen atom. Then afterwards students, now we are going to discuss about the Bose correspondence principle. What is meant by the Bose correspondence principle. The Bohr scientist how to the correspondence means how to the differentiation is obtained in between the orbital and next Bohr's atomic model. That principle is determined by the Niels Bohr scientist. How to this corresponding principle is or this principle is indicates means according to electromagnetic theory, an electron moving in a circular orbit. Yes or no, students? Everybody knows about this. According to the electromagnetic theory, an electron moving in a circular orbit with frequency nu should radiates electromagnetic energy. Then what happened here? When electron jumps from the one state to another state, the radiation can be emitted. So therefore, the orbital frequency of an electron, what is here? The orbital frequency of an electron revolving in nth stationary orbit is given by. So what we have to do? When the electron can be revolving around the nucleus in circular orbits, therefore the nth stationary orbit of the electron is given by nu orbital is equal to m e to the power of 4 by 4 epsilon naught square n cube h cube. This formula is obtained in a quantities of the hydrogen atom. In that frequency is obtained and time period of the an electron also determined, students. Yes or no? So therefore the frequency of hydrogen atom nu equal to m e to the power of 4 by 4 epsilon naught square n cube h cube. So this is indicated by the orbital frequency. When orbital frequency in that 1 by n cube we can take 1 by n cube into m e to the power of 4 by 4 epsilon naught square h cube. This is the equation 1. But according to Bohr's atomic model, an electron jumps from higher stationary orbit to higher stationary orbit n to lower stationary orbit m. Here n to m or n1 to we can take n2 to n1 we can have a what is the frequency of radiation is. So means according to the Bohr's atomic model, an electron can be revolving around the nucleus in circular orbit. When it is revolving in circular orbit, therefore the electron jumps from higher orbit to the lower orbit, higher energy level to lower energy level. Then what happened here? Its energy will be or energy will be emitted. That energy is contained in terms of the frequency. That frequency is represented by nu Bohr. See here, this is the nu Bohr at frequency equal to what we can write, that equal to m e to the power of 4 by 8 epsilon naught square h cube into 1 by m square minus 1 by n square. 1 by m square minus 1 by n square. Understood, students? Here this is the which frequency? Bohr's frequency. According to the Bohr's atomic model, here an electron can be revolving in a circular orbit. Therefore so it has contained the what is your orbital frequency. That's Bohr orbital frequency. Nu Bohr is equal to m e to the power of 4 by 8 epsilon naught square h cube into 1 by m square minus 1 by n square. This is equation 2. From equation 1 and 2 we get nu orbital frequency by nu Bohr frequency, and divide the what is equation 1 by we can take the what is 2, we will get the 1 by n cube into m e to the power of 4 by 4 epsilon naught square h cube whole by m e to the power of 4 by 8 epsilon naught square h cube into 1 by m square minus 1 by n square. So here m e to the power of 4, m e to the power of 4 gets cancelled. Epsilon naught square h cube gets cancelled. Remaining is 1 by n cube, 1 by 4 n cube, and here 8 1 by 8 into 1 by m square minus n square. So this we can take 8 take upward direction. Therefore nu orbital by nu Bohr is equal to, we can write 8 by 4 n cube into 1 by m square minus 1 by n square. So, 4 1s are 4, 4 2s are 8. So, therefore, 2 by n cube into n square minus m square. So, we can take the here, okay, n square minus m square by n square into m square. So, that is equal to 2 n square m square, take upward direction, 2 n square m square by n cube into n square minus m square. Therefore, nu orbit by nu Bohr's frequency is equal to 2 by n cube into n square m square by, so here a square minus b square shape. So, therefore, a plus b into a minus b we can write. So, n minus m into n minus m. When, okay, n is a very large or far greater than m, then what happen here? The m value can be write in terms of n minus 1. So, therefore, n minus m is equal to, we will get the 1, and most probably here n is approximately equal to the m. So, that is why when n is approximately equal to the m, therefore, what we have to do? Let us, we have to substitute this value in above equation 3, we will get the nu orbital by nu Bohr's frequency is equal to 2 by n cube into, so here n square, m is equal to n we can take, and m square is comes, n, okay, n square by, okay, n plus, okay, m equal to n plus n, 2n into here n minus m equal to 1. So, that is why we will get the what is here, okay, 2m into 1. So, okay, here, okay, 2 gets cancelled, n into n square n to the power of 4, n cube into n means n to the power of 4. So, here n to the power of 4, n to the power of 4 gets cancelled. So, we will get nu orbita by nu Bohr equal to 1. So, this is equation 4, or we can write nu orbital is equal to nu Bohr frequency. So, this expression is indicates the nu orbital frequency of an electron in electromagnetic theory is equal to the, okay, the orbital, what is here, the Bohr's frequency of electron in Bohr's atomic model. So, according to this, what happened here, the quantum theory and classical theory, they can explain about the frequencies of orbital and, okay, Bohr's atomic model. So, that is why, so according to quantum, okay, and classical theory, how to they can explain means, so this expression shows that means nu orbital is equal to nu, okay, Bohr's is, and this is the expression is equal to each other. So, that is why this expression shows that, okay, for large, okay, quantum numbers, the quantum theory, okay, arrives at the same results as arrived by the classical theory in physics. So, already what happened here, according to the nu orbital frequency is equal to the nu Bohr frequency. So, this can be obtained by the quantum theory of a large quantum numbers. For large quantum numbers, quantum theory can be determined the frequency. So, this frequency when it is determined, the same frequency can be determined by the classical theory in physics. So, this statements of Bohr's is known as a Bohr's correspondence principle. So, the quantum, okay, orbital frequency is equal to the classical orbital frequency is called as a Bohr's corresponding principle, students. Understood properly here? So, this is a very important for 4 marks questions. So, we should concentrate it. Okay. So, then afterwards, what are the, okay, limitations of the Bohr's, okay, theory? So, students, until and unless we have to study briefly about the Bohr's atomic model. According to that, we have to determine different, okay, energy levels and its quantities, and according to that series, different energy series. According to that, we have to determine the, okay, energy level diagram and orbital diagram. From that, we have to study about the, okay, here Bose correspondence principle also. So according to that, so here the Bose atomic model is explained okay, briefly about the okay, different futures are there and advances are there, but some of the okay, limitations or failures are contained in the Bose atomic model. What are they? Means here now let us we have to see the Bose theory of hydrogen atom fails to explain the following facts. The first fact is represented by this theory could not explain large atomic number elements than hydrogen. Only the Bose atomic model what is explained? Only okay, small atomic number of elements such as hydrogen, helium, but large atomic number of what is their elements does not explain by it. That's why it is a failure for okay, complicated atomic numbers of elements. The second is represented by this theory is failure to the distribution and arrangement of electrons in an atom. So what is the students here? The electrons are revolving around the nucleus in okay, circular orbit. He has explained. But how to these electrons can be distributed around the nucleus in stationary orbits? How to arranged? Okay, that can be does not explained by the okay, the Bose atomic model. Then afterwards, okay, the third failure of the or third postulates the limitation of a Bose atomic model is represented by it does not explain the experimentally observed variation in intensity of the spectral lines of an electron. So here okay, the Bose atomic model okay, the intensity will be changes. How to the intensity changes? The intensity changes, the spectral lines how to it will be changes, and the fine spectral lines are produced. How do these fine spectral lines are produced due to the intensities does not explained by the Bose atomic model. Then the fourth important point is this theory cannot be used to calculate about transitions from one level to another, such as the rate at which they occur. So here students, okay, this theory also failure for the transmission of atoms or electrons from one state to another state at the rate at which rate it will be occurring, that will be not explained properly by Bose atomic model. So now the fifth okay, limitation is represented by this theory could not explain the fine structure of spectral lines. So here students, okay, what is here? The okay, Bose atomic model explained only the spectral lines of the hydrogen atom, such as the Lyman, Balmer, Paschen, Beckett, Crand series. But in that the further small spectral lines, fine spectral and highly tuned spectral lines are produced. That okay, does not explained by the Bose atomic model. So this theory cannot be used for the quantitative explanation of chemical bonding. So in okay, atomic model, Bose atomic model, chemical bonds how to it will be occur? Chemical bonding, ionic bonding, covalent bonding, and okay, these are the how to it can be okay, contained, that properly not explained by the Bose atomic model. So the seventh is this theory cannot explain the Stark effect. What is here, students? Stark effect. What is the Stark effect here? When an electron can be contained in a what is a magnetic field. Okay, magnetic field. So then what happened here? Due to that magnetic field, okay, the spectral lines will be splitted. So how to these spectral lines is splitted by the what is here? Okay, magnetic field, that does not explain by the what is here Bose atomic model. That's why the spectral lines of the okay, external magnetic field is called as a Stark effect. What is the okay, Zeeman effect? And this theory cannot be explained. What is Zeeman effect? Means a weak electrical field, and here the external electric field is applied, then the spectral lines will be splitted. That spectral lines does not explained by the what is here the Bose theory. So that's why this is okay, due to the external electrical field, the spectral line is distributed, is called as a Zeeman effect. So, that is why this Bohr's atomic model does not explain the Stark effect and Zeeman effects. So, this is the complete briefly explanation of the atomic structure of an hydrogen atom. Thank you students. Thank you everybody.